I didn't see you walk in. Well, since you're here, why don't we talk about fractals? Now, some of the key concepts of fractals that I will go over with are infinitesimals, how they have an infinite perimeter but a finite area, their appearances in nature, and finally their uses. Let's talk about infinitesimals. Now, an easy example is the walking distance from here to this door frame. Now, to get from here to there, first I have to walk half the way, and then I have to walk half the way of the remaining distance, and half the way again. This is a key concept because in theory I can never make it through this door frame. However, I can disprove it by simply walking through. Now, this is a key concept in fractals as they go on into infinity. Now we're going to talk about how fractals are self-similar into infinity. The example we're going to use for this is the cock curve, or the cock snowflake. We start with a single line. Now, we then remove the middle segment of this line and replace it with two identical copies of itself, forming an equilateral triangle. Now, if we continually do this, on each side, we have the cock curve. Now, because we can keep adding triangles on and on into infinity, if we zoomed in and in on the cock snowflake, we would only find more triangles. In this way is the perimeter of the cock snowflake infinite, but it will never exceed a certain area. To talk more about this, we'll look at the coastline of Britain. Now, if we look at the island of Britain and measure the distance around the coastline, at first crudely, we get a certain distance. As we get more precise, we get another distance, and as we get even more precise, we get another distance. And as we get more and more precise, the distance will seemingly increase till the point where we can measure the distance between pebbles on the coast, and even the distance between atoms inside the pebbles. In this way, can the distance seemingly go on and on into infinity. Now let me make a distinction clear. This pen will never exceed the distance of 6 inches, but as the measuring gets more and more precise, the amount of distances we can get will go on into infinity. So, the amount of distances is infinite, but the distance itself cannot go on into infinity and surpass a certain point. One of the most famous fractals is the Mandelbrot set. Now, this fractal contains all other fractals and the patterns for all the fractals in nature. Sounds like a lot of fractals. Now, if we keep zooming in and into the Mandelbrot set, it seems like we don't see the same self-repeating image. But if we keep going on and on, we find it again and again at different points. The most interesting part of fractals to fractal mathematicians are the edges of the Mandelbrot set. Let's look at some examples of fractals in nature. River systems, lightning bolts, the capillaries in the human body, they all follow fractal patterns. A very good example is a leaf. Let's look at this one. For example, we see this shape, and then we add 2 to each side, much like the cock snowflake. And then we see again, the corners, if we looked close enough, resemble the whole. This is the property of self-similarity to infinity that all fractals share. And if we look at the branching out of the veins on this leaf, it is the exact same as the branching out of the branches on the trees. And also, once again, the same as the river systems, the lightning bolts. So, all these pictures are very cool, but what is the use of them? When asked that, one replies, what is the use of a newborn baby? You see, fractals were only recently discovered, and we don't know their full potential yet. But since we've noticed that everything in nature followed these patterns, there must be something great lying there for us to discover. So far, the only real practical use has been to make trees and mountains look really realistic in movies. But fractal geometry is something to be explored. So far, It is only intuitively understood because we ourselves are all fractals.